We'll now discuss some of the ways that we can delete array elements. Just as we had 3 different approaches for adding array elements, we have 3 options for deleting array elements. We can delete the element at the very end of the array, we can delete the element at the very beginning of the array, or we could delete a specific element somewhere in the array. Let's start by talking about how we can delete an element at the end of the array. Now, when we say we're going to delete an element, we're not physically deleting an array element. We're not unallocating the memory for that array spot. We're not removing it from the array. What we're doing instead is we just change our size variable, because that tells us how many elements are in the array, so we can just adjust that to tell us how many elements are left over, but also is a way to get rid of that last element. Now, before we can actually make that change, we do have to make sure there's at least something in the array before we start modifying the number of elements. So here's the code that actually lets us delete an element at the end of the array. So we pass the array and we pass the current size of the array. So all we're doing is checking as long as the size is greater than 0, so as long as there's something there, we can just decrease the value of size. And what that means is that element that was at the previous size -1 spot is now outside of the bounds of the array. So whenever we try to access array elements, we won't be using it anymore. We could set that value to something to say that it's no longer a part of the array, but it's not necessary, because if we were to add something to the end of the array, that value is going to get overwritten anyway. So we don't need to actually make any changes to that memory spot itself. Now, the running time of this is clearly O of 1 time. It's clearly constant time, because all we're really doing is just one comparison and then decreasing the value of size if that comparison is true. So what about deleting an element at the beginning of the array? Once again, we can't physically just remove that element and then make the second element be the first element of the array. That just kind of messes up the fact that we have a giant array for our memory allocation. Now, what we can do instead is we can replace the first element of the array with the second element of the array. So we can take A1 and store it into A0. And then we just repeat this for all of the array elements. So then we can store A2 into A1, store A3 into A2, until we get all the way to the end where we take A size -1 and store it into A size -2. And then we would just finish by decreasing the size of the array, because we have one less element in the array. Here's the code that takes care of deleting an element at the beginning of the array. So we still need to make sure there is something in the array. So we still have this if statement that makes sure that the size is greater than 0. And if this is true, we have our for loop here that will go through each element of the array. So we start where I is 0 and we go up to and including size -2. And the important part is this line right here. So all we're doing is we're taking AI plus 1 and storing it into AI. So we would store A1 into A0, and then the next iteration we'll store A2 into A1, and then we would store A3 into A2, and we go all the way until we get to the end of this loop. And then when we're done, we need to decrease the value of size by 1 because we have one less element in the array. So that's why we have to decrease it. Now, how much time does this take? Well, we're basically moving each element of the array. So just as we were inserting something at the beginning of the array and we had to shove all the array elements over one spot, we're doing the same thing here, except now we're moving everything to the other side. So really we're doing n-1 moves, so that pretty much becomes O of n. So this is an O of n time operation. What about deleting a specific element? Well, there are 2 parts to this approach. So the first thing is that we need to find the element. If we're saying we're going to delete some element, we have to make sure it's in the array, and specifically we need to know where it is before we can delete it. Now, how do we find the element? Well, we can take advantage of our sequential search algorithm. That's going to give us the index of the element that we want to delete, and then we can just say delete the element at that particular index. Now, what do we do after we delete that element, or how do we delete that specific element? Well, we can use the same approach as we did for deleting at the beginning, except now we're deleting at a specific element. so we can just move all the elements from that point onward one place. So we can do some overwriting from that place onward. Here's the code for deleting a specific element. So let's take a look what's going on here. So in the heading, the only difference between this and some of the other methods that we've called is now we have this item, and this is the item that we want to delete. So we first got to make sure that there is something in the array. So we still have to check that size is greater than 0. And then notice inside of here, we're calling our sequential search algorithm. So we're going to see, does this item exist in our array? And that's going to give us an index. And then we just simply need to put in our for loop that says we start at that index, and then we go to the end of the array, and then we just replace our elements just like we did before with deleting at the beginning. And then when we're done, we need to decrease the size by 1. Now, one thing I will mention about this code, there is one issue with it. And I want you to think about it for just a second. So if you need to, pause the video, but see if you can tell me if there's a potential issue with this particular code. One issue we have here with our index is, what if the item is not in the array? This code right here, while it's very simple, does not handle that case. So what we'll need to do if we wanted to fix that is we could add an if statement in here that says if the index is -1, we can print something that says that the array element cannot be found. And then if the index is not -1, then we would do all this. But that's just one thing you got to be very careful with, is that we want to make sure you handle all possible scenarios. So this particular code does not do it. So if we wanted to handle the case that the array element is not found or the item is not found, you need to make sure you add some additional stuff to this code to make it work. So what's the running time for deleting a specific element? Well, we have to consider the searching part of it. So since we are using sequential search, this does take O of n time to find the element or determine that the item is not in there. And then assuming that we do find it, we have to move all the elements starting at the index. This also is going to take O of n time. And that's because we have to consider the worst case scenario, which is the index is at 0. So if the item that we want to delete is the first element in the array, it's no different than deleting at the beginning of the array, where we have to move all of the other elements. So that means the total time for deleting at some specific spot is going to be O of n time.